Hi everyone, this video goes over page 30 in the Unit 8A packet. So the top of page 30 says, what's the difference between these two graphs? So we've got this solid graph and then this dotted graph. And when you look at them, you might just think, okay, well, the solid graph starts on the midline, so this is a sine graph, and the dotted graph does not start on the midline, so this is a cosine graph. That's true. But there is another way that we can differentiate between these two. What if I said, like, could I take one of these graphs and just move it over and have it match up with the other one? So if I took like the solid graph and I moved it over 2 boxes, which is really pi over 2, then the graphs would match up with each other. Or if I took the dotted graph and moved it backwards 2 boxes, or backwards pi over 2, since that's what 2 boxes is, then they would match up with each other. So actually every sine graph and every cosine graph can be written as one function if we think about shifting left or right. So down here it says, written in terms of the sine function, the solid graph is sine of x. We knew that one to be true. I'm going to just highlight this in my purple that barely works. So this is going to be sine of x. And then the dotted graph is, it could be a cosine function. And the dotted graph could be a cosine function, but look how else we can write this. So another way to write a cosine function is sine, but instead of just an x here, it's an x minus a number. So that like x minus a number is going to tell us how far to shift. Let me just So really, if I wanted to make this dotted graph, I would just have to move this purple graph over to the right 2 boxes, which is pi over 2. So the dotted graph is the same as the solid graph moved to the right 2 boxes, which is pi over 2. So this right movement of pi over 2 translates exactly to this right here. So this function, y equals sine of x minus pi over 2, in comparison to the original, just y equals sine x, the x minus pi over 2 is a shift to the right pi over 2. How do you think the graph of sine of x plus pi over 2 would differ from these graphs? So if it's a minus, we're moving to the right. So if there's a plus with the x, then we're going to move to the left. And another word for shift is translate. So you could say translate right pi over 2 or translate left pi over 2. All right, the practice on the bottom says identify the vertical and horizontal translations from the original graphs of sine of x and cosine of x. So I know that on the first one, this one only had to do with sine, and even the graph that looked like cosine, we wrote as a sine graph. Now, it doesn't actually matter. These function transformations will work with sine graphs, they'll work with cosine graphs, they'll work with anything. So basically, whatever number is with the x, that is going to indicate a left or a right movement. And that left or right movement is opposite of what you think. So if there is a minus, we're moving to the right. And if there's a plus with the x, we're moving to the left. So let's look at our first one, cosine of x plus 3 minus 1. So this right here, cosine of x plus 3, this is telling me that I'm going to shift, and because there's a plus, I'm going to move to the left. And in this case, it's 3 units. Now the number on the end is the midline. We learned that before. The midline is at y equals -1. But this also is the same thing as saying that we shifted down 1. Normally the graph is midline is at 0, 0, like the regular sine graph or the regular cosine graph. So normally the midline is at 0, y equals 0. But now it's at -1, so we could also call it a shift down 1 from the original graph. Let's look at number 2. So this is sine, and notice it doesn't actually matter whether it says sine or cosine, the transformations work the same way. X minus pi over 2. So x minus means I'm going to shift to the right. So I'm going to shift right pi over 2, and we know that our midline is at y equals 3. Another way to indicate that you have a midline of y equals 3 means you shifted the graph of sine up 3 units. So any number on the end, you could also call a vertical translation, so up or down. Let's look at 3. We've got x minus. So with the x, the minus means we're going to shift to the right. And in this case, pi units. And the number on the end is our midline still. Our current midline on this equation is 2. Normally, when there's nothing that's happened, a normal sine graph has a midline at 0. So if the midline used to be at 0 and now it's at if the midline's at 0 and now it's at 2, that means we shifted up 2. So the number on the end is indicative of an up or down movement. If it's a minus, you're moving down. If it's a plus, you're moving up. We've done these transformations before, just like with different functions. So this is similar to what you've seen for exponential functions and log functions and things like that. All right, you can do this with letters as well. So x minus m is the same thing as saying we shift. Minus means we're shifting to the right, m. And for the midline, we know the midline is at whatever negative n is. Since it's a minus, that means we've shifted down n. Now we don't have to have shifts that are both up, left or right and up or down. We can just have one. So notice on number 5, sine, and then we have a set of parentheses, and we don't have anything on the end. All right, if there's nothing on the end, that's like a 0. So this right here, x plus 3 pi over 4, is going to tell me to shift left 3 pi over 4 units. But the midline is still at 0. If you can't shift up 0 or down 0, nothing's going to happen. So this is no movement. Now on this one, notice that there's no parentheses. So no parentheses means there's no left or right shift. The only shift that we have is coming from the midline. So the midline, again, normally the midlines are at 0 of the basic sine and cosine functions. Now the midline is at 3. So this midline is at y equals -3. So this is a shift down 3. All right, there's a little bit about left and right and up and down shifts.